Welcome again. My name is Philipp Ebbecke, and this topic has already been announced by a couple of people in the last days. It's about the 6 gigahertz band, but this time just to focus on Europe. So we want to start with why do we need new spectrum at all? And then after that, we're going to talk about what is the 6 gigahertz spectrum as it is right now in Europe. After that, we're going to take a look at the state of the process as it is right now. And yeah, of course, we're going to end up with a conclusion and outlook. So let's get right into it. Why do we need new spectrum? Wi-Fi, simply as that, is a growing business. And Wi-Fi Alliance last year did a study called The Value of Wi-Fi, where they tried to put on a price tag on the unlicensed spectrum so that they can show everybody that there's really a high value, although you don't have to pay for using these licenses, these frequency bands. And for the year 2018, the global value was nearly $2 trillion, which is market capitalization of Apple and Amazon combined. And they also outlined some of the biggest industry nations over there and gave an outlook what they expect to be, what the value going to be in 5 years' time, in 2023. But okay, these numbers are hard to remember. Well, one thing that you can easily remember is, well, every year we get new devices into the market. 4 billion devices, chipsets, are going to be sold this year alone. So that's about 100 devices every second, more than 100 devices every second, new Wi-Fi chipsets released to the market. And we've heard Mark talk about it, that people nowadays only can live for 40 minutes without Wi-Fi. So we can definitely conclude that society needs Wi-Fi nowadays. Also operators, although they don't really admit it, they do a lot of Wi-Fi offloading to give people the bandwidth that they really need. And yeah, of course, also businesses nowadays rely on the unlicensed band of Wi-Fi. Like every logistic firm now, company now has a handheld device wirelessly connected to do all the logistics inside their buildings. But the question is, when was the last time that spectrum was globally allocated for Wi-Fi? Does anybody know that? When was the last time? I mean, we got 20 years of Wi-Fi. Huh? Well, 2003. 16 years ago, it was the last time that there was spectrum allocated for unlicensed usage. On the other side, the mobile services, whenever they release a new generation like 3G, 4G, 5G, they always fight for new spectrum to be used. Okay, they pay for it. They got licensed band, but they managed to get new frequency band for new use cases, and they are also a growing industry. I mean, you mostly do studies to prove a point that you already know or you want to prove. And Wi-Fi Alliance also did a study in February 2017 where they looked at the so-called spectrum shortfall. And in this case, I show you the graph for Europe. They calculated some kind of demand that would be needed to get things going, to have enough bandwidth for the people. And you can see for 2020, the average use case expected more than 500 megahertz of spectrum. And there's a so-called high demand. That's a bit higher, of course. And 5 years later, you see that we already go up to 1 gigahertz or even more if you take a look at the high demand. That spectrum that's needed additionally to the one that we already have. On the other hand, politics already started talking about so-called gigabit society. That's true for the WAN link, if you talk about fiber to the homes. But if you take a look at Wi-Fi, you need 80 megahertz channels to offer this 1 gigabit of throughput. If you really get their net throughput, let's see, but everybody can agree on that 40 megahertz is not going to give you 1 gigabit so far with the stuff that we have. Taking a look at Europe, we only got 1 80 megahertz channel in a DFS-free band. And in Uni 1, Uni 2, Uni 2A, there are up to 4 80 megahertz channels in Europe, and that's it. And most of you, all of you know it. you usually configure your devices to operate on 20 or 40 megahertz and not go for 80 or even 160 megahertz of channels because spectrum is a scarce resource. So we conclude there seems to be a demand. We haven't had spectrum for a long time. But why 6 gigahertz? How did you come up with this? Okay, first the properties of 6 gigahertz. It's got good propagation. You can do long range, whatever long range really mean. And it does allow high performance. If you go sub 1 gigahertz, you get really long range, but you don't get that much of performance. If you go up the frequency ladder, like 60 gigahertz, you get a lot of performance, but you really get a small range where you can operate on. So 6 gigahertz combines these two. It has a rather long range, and it also offers you high performance. And for chipset vendors, it's quite easy to extend the current products for 5 gigahertz up to 6 gigahertz. One thing that you are getting told nowadays is that the propagation is nearly the same like 5 gigahertz. So what this is going to end up, it's, well, we have to see until the finished product. We can test it. We can see if if there are any major changes to the design rules that you already have today. And last but not least, something that's quite unique for 6 gigahertz, we had a good potential for a global harmonization. So it could lead to 6 gigahertz all over the world. I know America is pushing for it. Europe is pushing for it. Asia, Africa, they still need to push for it as much as we do over here. And you might ask yourself the question, how do we get new spectrum at all? Well, that's where the ITU, the International Telecommunication Unit, comes into play. They assign specific services to frequency band. They do so at a so-called World Radio Communication Conference, which is held every 4 years. For every 4 years, a lot of people, all from all different nations, come together, get locked up for 4 to 5 weeks, and figure out which services they can allocate to different bands. And 6 gigahertz, I couldn't figure out when that happened, but 6 gigahertz already has a so-called co-primary mobile allocation. And that's something we can use as Wi-Fi, as we are a mobile technology. But co-primary means, yeah, there are other services that are primary and secondary users of the band. Just like radar in 5 gigahertz is a primary user, and we are only a secondary user there. But in this case, we even got a co-primary. And what co-primary really means is there are existing systems in the band. And we have to protect them as a new contender for this band, which means we should make sure that we don't do them any harmful interference. What harmful interference really mean? Chuck Lukaszewski did a talk like this at WLPC in Phoenix, and he gets more into the details, the technical detail, what harmful interference is. It is really defined in ITU level documents. I don't have the time to get into it, and I'm going to spare you from that one. The 6 gigahertz spectrum in Europe. So what is out there right now? What are the contenders that we are facing? Well, first, what is Europe really? It's European Union, it's Europe, and it's also some others. And the one thing that operates all the frequency bands is CEPT. The European Commission, which is part of the European Union, they mandated CEPT to investigate the band of 5.925 up to 6.425. And CEPT, for the French people, is Conférence Européenne des Administrations des Postes et des Télécommunications. Okay, easy. It's the conference of the European Administration for Postal and Telecommunications. The European Union has 28 member states, except if Brexit's going to happen, it's going to be 27. But even if Brexit takes place, the UK is still going to be part of CEPT. CEPT supersedes the European Union, and it has 48 member states. So states like Switzerland, they are not part of the European Union, but they are surrounded by countries of the European Union. So you can imagine what happens if all the European Union countries start to deploy 6 gigahertz. the frequency is not going to stop at the border for Switzerland. They're going to face all the interference in 6 gigahertz from all the countries around them. So it's kind of good that they are also taking part in these studies. Some smaller ones, like Vatican, is also part of TEPT. Turkey, even it's not really that much a European country, still in there. And last but not least, the Russian Federation is also taking part in CEPT. As you might already have heard, the USA, in this regard, the FCC, they are investigating much more spectrum. They go up to 7125. So they look at 1.2 gigahertz of spectrum, whereas Europe only looks at 500 megahertz, the so-called lower 6 gigahertz band. The reason behind this is, well, we got 48 member states, not only one country that tries to offer spectrum. So 48 member states with different ideas, what's going to happen, different incumbent systems. They want to make sure that the incumbent systems are protected. And they got some critical stuff in the upper 6 gigahertz band. So that's why they only said, yeah, let's start with the lower band. See how that works out for you. But the idea, especially from the Wi-Fi industry, is we want to take a look at the lower 6 gigahertz. And if we can prove that we can make it work in the lower band, we want to make the European Commission investigate the upper 6 gigahertz band as well. So it's not a done deal that we might not get up to 7125. Well, let's see. So what are the incumbent, the existing systems in 6 gigahertz in Europe? It's a bit different than in the US, but there are a lot of common stuff as well. First of all, fixed services, point-to-point applications. It's a very important service, and the national regulatory authorities are pretty neat about this, because operators, they have deals with clients where they tell them, okay, we are going to get this quality of service out of the link, and I'm guarantee you the 4 nines, the 5 9, the 99.999, whatever availability of your link. And something that Wi-Fi has, like Keith said, we got a robust standard. We can do adaptive modulation coding schemes. We can drop our modulation coding scheme if something is happening which is interfering with us. These guys, they have 64 QAM. That's it. They operate on 64 QAM. And if the interference raises, nothing can be done. They can't drop down to any lower QAM modulation scheme. And you can also see that relocation of these antenna masts is kind of difficult, and it's expensive to do. But European countries have a varying amount of these fixed links. I can show you an answer that we got when we asked for how many fixed links. I'm sorry, these are kind of small to read, but you can see there are some countries with a very high amount of fixed services, and also some countries that only have a very low amount. The highest one, Russian Federation, followed by France, followed by Italy, Spain, Germany, Norway. And there are also some smaller countries like Estonia, Luxembourg, who don't have any fixed links. So different interests are combined here. Another service, fixed satellite services. For this band, it's the uplink, so Earth to space communication. The equipment that's up there is operated for multiple years, centuries, whatever. So you can think relocation or replacement is not that easy. It's very costly, or maybe not even possible to do. And since they are so high up there, they are covering a very large area, and they get a lot of interference from this area combined. So they are especially sensitive to outdoor Wi-Fi deployments, as there is no wall, anything like this, trying to attenuate the signal that they see up there. A rather interesting incumbent, the so-called Road Intelligent Traffic System and Communication-Based Train Control. The easy example is autonomous trains. We got some of them in Paris for some lines, and also in Copenhagen. They need the communication to have a secure and safe operation of the trains, because there's no one in there to stop them. The beauty is they only reach into the lowest part of the lower 6 gigahertz band. They go up to 5935. So they're not incumbent for the whole 6 gigahertz band. And there are only a few deployments so far that operate on autonomous trains. But just like Wi-Fi, we want to have a harmonized standard across Europe for the lower 6 gigahertz band. They also aim for a harmonized standard to deploy CBTC. And as we've heard before, we want to save the environment. Public transportation is something that really tries to achieve this. So CBTC deployments might rise up in the near future. And that's a special case. Radio astronomy, looking for matter in space. There are only a few sites, about 19 in Europe, and they try to look for some special material in space to say there's a life form out there. And I've given you the frequency for methanol. Okay, it's not in the lower part of the 6 gigahertz band, but it's really a small amount of the band, a small portion of the band where they have to look for these methanol in space. So they are really looking out for any interference that might destruct the signal that they have. But since there are only 19 sites in Europe, this is rather a national issue and not a European one. So there might be some special national regulation applied to this. And last but not least, something that came up with the iPhone 11 launch now, much more, the ultra-wideband, or as we can call it, a user with no rights. Up to today, there's only mainly sensor and ranging applications for this. They can use the 6 gigahertz band, but they have to make sure that they do not interfere with any of the incumbents that are out there. But not vice versa. So that means ultra-wideband has no right to be protected. We as Wi-Fi don't have to care about if we do any harmful interference to ultra-wideband. Okay, let's talk about the state of the process in Europe. Is anybody doing spectrum and regulatory affairs? I hope. Different playing field. Okay, there are basically two groups in CEPT. The spectrum engineering group, which is doing technical studies, all this interference stuff to incumbent systems, what's happening. They try to create a report, the so-called Electronic Communications Committee report, where they put all the studies in. And on the other hand, there's the frequency management group. They try to design the regulatory and technical rules to deploy Wi-Fi. And they create so-called CEPT reports. And in our case, it's SE45. They just increase the number whenever a new group is founded. SE45 creates the ECC report, and FM57 creates two separate reports called Report A and Report B. Furthermore, there's also ETSI involved, the European Telecommunications Standard Institute. And we need the ETSI standards for self-certification. That's a vendor perspective. And these ETSI standards, they include the rules if we want to deploy Wi-Fi in the market, like DFS rules, out-of-band emission, stuff like this. The work in ETSI is usually carried by companies, chipset vendors, device vendors, and also regulators. And some further work that they do, they sometimes put out system reference documents where they try to describe the technical elements of a certain technology. Why am I telling you this? This all leads to this slide. This is the current state of the timeline in Europe. So we can see a lot of work has happened in this year, 2019. In 2017, FM57 and SE45 was created. We got the European Commission mandate to study these frequency band. We started the sharing studies. And ECC report 302, that's the one that SE45 created, was approved in May. So we're done with the technical studies. And we also got a first report from the FM57 called Draft Report A. And it might be approved soon. So all we have to do right now is we try to get to a Draft Report B, which will be our final report, where the regulatory and the technical stuff will be in. And you can see the outlook is we want to have the final report B delivered in July 2020. And if that happens, there might be a small window between end of 2020 up to 2021 where the European Commission or the ECC, which is the CEPT in this case, can vote on and can say, yes, your studies are good. You can start deploying your Wi-Fi in the band. So like US, we could also end up in 2021 with some equipment. But there's also the line down here where ETSI has to do some work. And they just started a work item to put out a standard for 6 gigahertz in ETSI, which is then required for self-certification by vendors. And they aim for mid of 2021 or maybe a bit later to publish this standard in the so-called official journal of the European Union. And that's really when you can go and do self-certification. Now, if you want to get into the details, you can all read the ECC report 302 if you're up to it. It includes studies of sharing and coexistence of Wi-Fi with the incumbent system that I just introduced to you. And the outcome and the conclusion that were drawn from this report, they were given to FM, to the group FM57. The CEPT report, which was called A, it now got a number, is nearly complete. And it says, coexistence between WAS-RLAN, wireless access system, radio local area network, or as you know it as Wi-Fi, and existing services within and adjacent to the band will be technically feasible under certain conditions. So what they're saying is, yes, you can do it, but these are the conditions. And now we're going to get back to what you already heard before. There's a very low power coming into play. It says low power indoor operation is okay, and outdoor, only very low power on mobile devices. There's no other outdoor usage other than the very low power portable devices. And there's not going to be any high power in Europe. Now, what's the question that comes into your mind?
What is power?
Yeah, what are the power levels? Yeah, and that's really the work of CEPT report B, and whatever number this is going to get. They want to define the exact power levels. Just like in FCC, they're also talking with some terminology like standard power or high power, low power, very low power. And they also want to bring down the exact frequency range for Wi-Fi usage. And there might also be some other regulatory requirements. And as stated before, yes, from ETSI, we also need a standard to ship stuff to market. And they're going to base their work on this CEPT report B, where you got rules for the transmit power, out-of-band emission, transmission time, all of this. It is required for self-certification, but there's a but to this. If we are getting a stable draft quite soon, we can go to a so-called notified body, which is usually a lab. We can say we want to ship this to the market. Are you okay with this based on the stable draft that we already got? It costs a bit of money, but it saves you a lot of time to market. Okay, drawing up the conclusions. Like David Coleman already said, we are almost there. We can touch it nearly. We all have the feeling that the lower 6 gigahertz band will also be opened up soon in Europe, which comes with 480 megahertz of spectrum for Wi-Fi, 24 new 20 megahertz channel, or at least 680 megahertz channel. There's going to be a small guard band of 10 megahertz at the lower part and at the upper part, or maybe combined at the lower part and no guard band at the upper band. That's stuff that they now try to get done. Which means we only get one band. It's not Uni 1, Uni 2, Uni 2A, stuff like that. It's just one band, one power level for access points and clients indoor, and the exception, one power level for mobile hotspots. There's no radar, no DFS involved. Yes. And the idea is, once we get an ECC decision, CEPT decision, this is going to open up a huge market with 48 countries where you can deploy 6 gigahertz Wi-Fi. Well, there are some showstoppers. Like I told you before, ITU, World Radio Congress, this year, a lot of people get locked up for 4 to 5 weeks in Sharm el-Sheikh at October, November. And there's an agenda item for identification of the 6 gigahertz band for mobile service, which is operator, or the 5G, 6G technology that might come out. They want to have a shot at the 6 gigahertz band. And if this would happen, all the Wi-Fi stuff would be delayed. No one would touch this, because usually when mobile service gets into the band, everything else gets out. There's going to be a lot of discussions and who's in favor of this, who's not. I can say America wants to have Wi-Fi and 6 gigahertz. Europe, for most, wants to have Wi-Fi and 6 gigahertz. Asia, not so much. So we're going to see how it ends up. It might also be that they, with the mobile service, end up in the upper part of the 6 gigahertz band, where we can enter the lower band. So it's a lot of politics involved in this. And as I told you before, we also need ETSI to work on this very quickly to at least have a stable draft that we can go and certify devices with a notified body. And last but not least, these studies that I've showed you, they are basically technology neutral. And also 5G, this is the technology called New Radio, they are also looking, just like LAA, for an unlicensed usage. So if we open up the band, we still might end up with Wi-Fi and so-called 5G New Radio unlicensed in the band as well, because they can just use all the rules that we've set up just like we do. And that's basically the state of the process in Europe. Thank you very much.